Welcome everyone, Mike Fave here. Today I'm back with a new study. However, I'm going to change the format on this study and I'm going to try to make it a bit more concise and a bit more condensed, get it done in maybe 10 to 15 minutes. Now this study is a bit easier to go through than some of the other studies that I've gone through before, such as the statin study or the obesity study. But either way, regardless, I'd like to see what your guys' input is on this format. Perhaps you like this a little bit better. So without further ado, let me jump in here. Today's study is titled Dietary Lipids Modify Redox Homeostasis and Steroidogenic Status in Rat Testes. Essentially, what we're going to be looking at is the effect of polyunsaturated fats compared to monounsaturated and saturated fats on testicular function in rats. So let's jump right in. They start with the experiment. They basically took 40 male rats. They divided them into 4 separate groups. Their diet and everything was the same. The only thing that changed was the fat content in their diet. So 10 male rats were fed coconut oil, 10 male rats were fed olive oil, 10 male rats were fed soybean oil, and 10 male rats were fed grapeseed oil. Now, what does this look like in terms of fatty acid composition? So here we have the fatty acid composition of the rat's diet as a percentage. Now, we have this S group here is the soybean oil fed rats. The O group here is the olive oil fed rats. The C group here is the coconut oil fed rats. And the G group here is the grapeseed oil fed rats. Now, if we slide down to the bottom, you'll see this big red box here that I highlighted for you guys. What this shows is the sum of the different types of fats in the diet. So they have some of saturated fatty acids, some of monounsaturated fatty acids, some of polyunsaturated fatty acids. And then basically each column corresponds to the diet title or the diet title above. So basically what we're looking at is we have a very low PUFA, high saturated fat diet with the coconut oil diet coming in at 94.6% saturated fat, 4.1% monounsaturated fat, and 1.3% polyunsaturated fat. Next, we have a very high monounsaturated fat in the form of olive oil at 70.8% monounsaturated fat. It's mostly oleic acid. 8.4% polyunsaturated fat and 20.7% saturated fat. So again, the olive oil diet was a lower PUFA, high monounsaturated, maybe lowish to moderate saturated fat diet compared to the coconut oil, which was a high saturated fat, low monounsaturated, and low polyunsaturated. Now, the next 2 diets that are left was the soybean oil and the grapeseed oil. Both of these are high polyunsaturated fat diets. The only difference between these 2 diets was that the omega-6 to omega-3 ratio, where the soybean oil diet had a much better ratio of omega-3 to omega-6, meaning that the omega-3 content was closer to the omega-6 content. The ratio here is something that's been discussed in terms of inflammation due to the modulation of omega-3s on some of the inflammatory enzymes and the conversion processes into the inflammatory mediators known as the eicosanoids. So having a better omega-3 to omega-6 ratio has been associated in some research with less inflammation overall. Next, the soybean oil was representative, having a decent omega-6 to omega-3 ratio. The grapeseed oil diet was the high PUFA diet that indicates a poor omega-6 to omega-3 ratio at 654 times 654 times omega-6, more omega-6 than omega-3 versus in the soybean oil diet, 7.9 times more omega-6 than omega-3 as per the ratio. Now, both of them are about, the soybean oil was 62% polyunsaturated fat. The grapeseed oil diet was 65% polyunsaturated fat. So they're both quite high in polyunsaturated fat. The monounsaturated fat in the soybean oil diet's a little lower, where it's a little higher in the grapeseed oil. And then vice versa for the saturated fat, where the soybean oil diet had a little higher saturated fat and the grapeseed oil had a little less saturated fat. So what we're looking at here, again, is really that the grapeseed oil and soybean oil are both high polyunsaturated fat diets, and just the soybean oil has a better omega-6 to omega-3 ratio than the grapeseed oil. So 4 diets: coconut oil is saturated, olive oil is monounsaturated, soybean oil is polyunsaturated with a good omega-6 to omega-3 ratio, and grapeseed oil is polyunsaturated with a crappy omega-6 to omega-3 ratio. So those are our 4 experimental groups. Last thing I want to bring your attention to, these little skinny highlighted sections that I have here. The red one is for omega-6 and the green one is for omega-3. All I was showing, or all I wanted to show to you here, is that pretty much the grapeseed oil, coconut oil, and olive oil are very poor in omega-3, whereas the soybean oil has a bit more omega-3 at 6.8%. And then the olive oil and coconut oil are quite low in omega-6. Now, something that I want to point out to you at the moment, and I'll discuss this in a little bit, is that the olive oil had 8.2% omega-6. So it has a little bit more. Ray typically recommends, I think, getting 2% of your calories as, or less than 2% of your calories as polyunsaturated fat. So that would be, that's his 2 grams or his 4 grams per 2,000 calorie recommendation. So this olive oil technically would be above that, and I think that'll come into play in just a bit. There's also some interesting studies with A.J. Holbert in the membrane pacemaker theory, which I want to touch on with the olive oil piece in just a bit as well. Soybean oil, 55% omega-6, and in grapeseed oil, 65%. But the main piece here is the coconut oil is only 1.3% omega-6, basically has negligible omega-3, and then the olive oil, negligible omega-3, and still has a little bit of omega-6, and we'll talk about why that's important in just a few minutes. Now, what actually was tested with these different diets? What were they looking to see happen, or what were they checking to see where the dysfunction was with these different types of fats? So the first thing they looked at was body and testicular characteristics of the rats. This is like what their body weight is, what the relative weight of the testicles are, etc. Oxidative stress in the rat's testicles, blood hormone levels, hormone content of rat testicles, and steroidogenic enzyme function. So the oxidative stress, that's pretty self-explanatory. The blood hormone levels, we're talking about testosterone, estrogen, LH, FSH. The hormone content of the rat testicles, we're talking about the testosterone content. And steroidogenic enzyme function, we're talking about the enzymes involved in the production of steroid hormones, including testosterone, inside the testicles. So what is the effect of these different types of fats on all of these functions altogether? The first thing we're going to talk about here is the body and testicular characteristics of the rats. So first things first, the heaviest rats altogether wound up being the coconut oil fed rats, whereas the lightest was the grapeseed oil. So the rats fed the coconut oil had the greatest amount of body weight gain. They had the fastest rate of body weight gain. They had the best food efficiency ratio, meaning they were best able to convert the food that they were eating into actual body tissue. It doesn't necessarily tell us here whether that's fat or lean tissue. I'm sure there's a decent amount of fat. We won't talk about that for this specific paper here because we don't know. And then now what they're looking at is the absolute weight of the testicles. So in terms of absolute weight of testicles, the olive oil group and the coconut oil group had the heaviest testicles overall. And they also had the largest relative weight of the testicles, which is the weight of the testicles in milligrams divided by the body mass of the rats. So the animals with the largest testicles overall and in ratio to their body were the olive oil fed rats, and then in second was the coconut oil fed rats. The grapeseed oil and the soybean oil fed rats came in much less than the olive oil and the coconut oil. And as we're going to see as we go forward, this is going to be a continuing trend for these poor soybean oil and grapeseed oil fed rats. Now, next thing they looked at was oxidative stress in the rats' testicles. So a lot of the oxidative stress they were looking for involved looking at different assays that test lipid peroxidation products from polyunsaturated fatty acids. So the first one here that they looked at is the T-bars, which is the thiobarbituric acid reactive species test. And so this test looks at lipid peroxidation specifically. And what we'll see here is that the olive oil and coconut oil fed rats had the lowest T-bar scores, meaning they had the least amount of lipid peroxidation, whereas the soybean oil and grapeseed oil fed rats had significantly more lipid peroxidation than the olive oil and the coconut oil fed rats as per the T-bars assay. Now, for grapeseed oil had almost 3 times as much T-bars as the coconut oil group and a little more than twice as much than the olive oil group. The soybean oil had about a little more than twice as much than the coconut oil group and about twice as much of the olive oil group. So not so good overall. As we look over here, we're going to look at lipid peroxides. Again, a marker of like exactly what it is, lipid peroxidation. So coconut oil and olive oil, again, had the lowest amount of lipid peroxides compared to the soybean oil and the grapeseed oil group, with coconut oil having almost 1/4 of the amount of lipid peroxides as the grapeseed oil group and 1/3 the amount of the soybean oil group. The olive oil group was about 1/3 of the grapeseed oil and about, it looks like, a little less or a little less than 1/2 of the soybean oil group. So basically, again, as far as lipid peroxidation, the olive oil group and the coconut oil group doing the best overall. Now, conjugated dienes, these are, again, another marker of lipid peroxidation. The coconut oil group and the olive oil group had significantly less conjugated dienes than the grapeseed oil group and the soybean oil group, with olive oil coming in 1/5 and 1/6 compared to the soybean and grapeseed groups respectively, and the coconut oil group coming in about 1/3 of conjugated dienes to soybean oil and grapeseed oil groups. So again, if you want to limit, so far from this perspective, if you're trying to limit your lipid peroxidation inside your testicles, I guess at least if you're a rat, then using olive oil and coconut oil would be the way to go. Next thing they looked at was fragmented DNA as a percentage. The fragmented DNA is indicative of apoptosis, or the self-destruction or suicide of cells inside the testicles. The coconut oil and olive oil group were about a half of what the soybean oil group was in terms of percent of fragmented DNA, and 1/3 of what the grapeseed oil group was. So the grapeseed oil group so far is performing the worst out of all four of these groups. Soybean oil isn't as bad as grapeseed oil, but it's not close to as good as olive oil or coconut oil. The last one, or not the last one, the next one that they tested was the ferric reducing ability of plasma. This is a measure of antioxidant capability of the tissues that they're testing here. Basically, they take iron, they put it in a solution. The iron has an oxidative effect, and then the tissue or cell, whatever they use inside this assay, is basically they measure how it's capable of buffering the oxidative stress induced by the iron. So the coconut oil and the olive oil performed the best, which means that the testicular component, or the testicular homogenates here, the tissue that they kind of ground up for this assay, had a much higher antioxidant capacity than both the grapeseed oil and the soybean oil. It looks like the coconut oil and olive oil are about 2 times the amount of antioxidant activity as the grapeseed oil, and about 1.5 times that of the soybean oil. Last one here is for the free radical section is the protein carbonyls. So protein carbonyls are a marker of protein oxidation, specifically usually via polyunsaturated fatty acids and lipid peroxides. And what you're seeing here is that the coconut oil group and the olive oil group have about, 1/4 and 1/3 the amount of protein carbonyls as the grapeseed oil group, and about 1/2 and 1/3 of the soybean oil group. So again, coconut oil and olive oil for the win so far. When we get down here, we start to look at antioxidant levels. The highest amount of vitamin C. So vitamin C is the water-soluble antioxidant, and then alpha tocopherol is the fat-soluble antioxidant. These are much higher inside the olive oil and the coconut oil groups than the grapeseed oil and the soybean oil group. So what you want to see here is you want to see higher levels of antioxidants, because it means they're not getting used up in these oxidation or peroxidative reactions caused by the lipid peroxides and reactive oxygen species. So the olive oil group and coconut oil group had the most amount of vitamin C and the most amount of vitamin E compared to the grapeseed oil group and the soybean oil group. And they're like almost multifolds higher, multifold higher. So again, olive oil and coconut oil for the win. Now, the next thing they looked at is protein thiols. So protein thiols are components or side groups of proteins that are able to help to detoxify lipid peroxides and have a bit of an antioxidant effect as well. And what we're seeing here is that you almost have twice as much of these protein thiols present inside the olive oil and coconut oil groups compared to the grapeseed oil and the soybean oil. So basically, the antioxidant status inside the testicles of the rats fed olive oil or coconut oil is significantly better than the rats fed the soybean oil or the grapeseed oil. The last thing they're looking at is the reduced glutathione in ratio to the oxidized glutathione. So glutathione is one of the master antioxidants in the body, and what it does is it helps to deal with reactive oxygen species, lipid peroxides, free radical formation, etc. And the ratio of reduced glutathione to oxidized glutathione indicates oxidative stress. When the glutathione, when this reduced glutathione interacts with these reactive oxygen species, it donates electrons and then it becomes oxidized. So the reason it's called reduced is, again, the electrons have a negative charge and they're added on to the glutathione's structure, adding or depending on how many electrons it holds, adding negative charge to it, meaning it's being reduced. Now, what you're seeing here inside the olive oil and coconut oil groups is that there's, let's see, the olive oil compared to the soybean oil, it looks like there's almost 4 to 5 times, or it looks like 4 times as much reduced glutathione inside the olive oil group in ratio to oxidized glutathione compared to the soybean oil group. And then in the coconut oil group, there's about almost 3 times more reduced glutathione to oxidized glutathione than in the soybean oil group. The grapeseed oil group is even worse than the soybean oil group, coming in significantly lower than the soybean level, so multiple times lower than the olive oil and the coconut oil groups. So overall, what we're seeing with this picture is a much higher amount of lipid peroxidation and damaged proteins and apoptotic cells inside the soybean oil and the grapeseed oil groups, and compared to the olive oil and coconut oil groups, and in the olive oil and coconut oil groups having much higher amounts of antioxidant compounds like vitamin C, vitamin E, the protein thiols, and glutathione. So overall, so far, in terms of oxidative stress, if you don't want to explode your testicles, if you're a rat, I guess, then olive oil and coconut oil would be the way to go. Next thing we're going to look at is, so we know that the grapeseed oil and soybean oil, these high polyunsaturated fats, cause oxidative stress inside the testicles, but what does that do to hormones? What does that do to the actual hormones secreted by the testicles into the blood? So this slide here, we're looking at rats' blood and testicular hormone levels. Now, what we're seeing again, the S is for the soybean oil group here, the O is for the olive oil, C is for coconut oil, and G is for grapeseed oil. The first things we're looking at is LH and FSH. These are pituitary hormones. These are hormones released by the pituitary gland to signal the production of testosterone and the production of semen or sperm. Now, what we're seeing here is there's a much higher LH and FSH in both the soybean oil group and the grapeseed oil group compared to the coconut oil group and the olive oil group. This is not good. This isn't necessarily very good. Why? Well, the hypothalamus, the hypothalamic pituitary axis, is is basically reading what's going on hormonally with the testicles and saying, hey, things aren't working out so hot. We need to increase production. So the way at least I'm interpreting this is that the hypothalamus pituitary is saying, hey, the testicles aren't working so well, so let's trigger them. Let's signal more hormone for them to produce more testosterone. Now, we'll see what happens. Is the testosterone actually low in these soybean oil and grapeseed groups compared to the olive oil and coconut oil? We'll talk about that in a sec. But you're seeing a lower signaling from the hypothalamic pituitary axis in the olive oil and coconut oil groups compared to the soybean oil and the grapeseed oil groups. And my hypothesis, and we'll see in a sec, is that it's because the soybean oil and the grapeseed oil is impairing testicular function in the hypothalamic pituitary axis, saying, hey, come on, boys, you got to make the testosterone. So now what we're going to look at is the free testosterone and bound testosterone. And this is in the serum or in the plasma. In the olive oil and coconut oil groups, the free testosterone is significantly higher than both the soybean oil and the grapeseed oil, and the bound testosterone is significantly higher in the coconut oil and the olive oil groups than the soybean oil and the grapeseed oil groups. So what we're seeing is that the coconut oil and olive oil groups, those rats' testicles, are producing adequate amounts of free and bound testosterone with a decreased input from the hypothalamic pituitary axis, meaning that their testicles are working well without this need of the stimulus from the hypothalamic pituitary axis. This is a good thing compared to the soybean oil and the grapeseed oil groups. Now, the next thing we're gonna look at here is the ratio of free testosterone to bound testosterone. This was significantly better in the olive oil and the coconut oil groups as well. So overall, the olive oil and coconut oil groups had a better free testosterone to bound testosterone ratio. They had significantly higher free testosterone, although it doesn't seem that their bound testosterone was significantly different. And they had significantly less LH and FSH. So the rat's testicles were producing enough hormone. That hormone was able to be unbound from the carrier proteins like sex hormone binding globulin and albumin in the serum and able to affect the target tissues better than the soybean oil and the grapeseed oil groups. Now, the one thing we'll see here is that in the olive oil and coconut oil group, they had a higher amount of estrogen or estradiol than in the soybean oil and the grapeseed oil group. The reason I think this is because these rats had more free testosterone available and more testosterone available overall to convert into estrogen. Now, I don't know what was in the rest of their diet. We could actually look it up, but I don't want to speculate on that too much. But I would assume that the rest of the rat's diet may have an impact on how that testosterone is converted, whether it aromatizes more heavily or is converted more in towards DHT or other steroids, like other downstream steroids. So what I think here is that just with the increased amount of testosterone available, the rats had more substrate to be converted into estradiol. So yeah, that's essentially what I think is going on with the higher estradiol, but overall better testosterone levels from the free perspective and a better free to bound testosterone ratio with less input of LH and FSH. And the rats had a non-significantly higher amount of total testosterone in the olive oil and coconut oil groups compared to the grapeseed oil and soybean oil groups. Last thing we're going to look at, so this was all in the plasma. This is what's going on in the blood. So what's actually going on inside the testicles? Well, inside the testicles, the amount of testosterone present was significantly higher in the olive oil and the coconut oil groups than the soybean oil and the grapeseed oil group. The grapeseed oil group is sad. It's like half the amount of testosterone present compared to the coconut oil group and the olive oil group. The soybean oil group is a little closer. Maybe 2/3 of the coconut oil group and a little more than that for the olive oil group, but overall still significantly less than the olive oil and coconut oil group. So now, where are we at now? Essentially, if you want more oxidative stress, less antioxidants, less testosterone in your serum and in your testicles, then consuming soybean oil and grapeseed oil is a great idea. However, on the flip side, if you would like to have decreased oxidative stress, increased antioxidant compounds, higher testosterone, less hypothalamic pituitary axis input on the testicles to produce testosterone, and then higher testosterone inside the testicles as well as the serum, olive oil and coconut oil would look like those are the fats to go with. So now what we're going to look at is, okay, how are the enzymes in the testicles functioning in terms of steroid production? So we have two enzymes here. We have 3-beta-hydroxysteroid dehydrogenase, and we have 17-beta-hydroxysteroid dehydrogenase. Now, 3-beta-hydroxysteroid dehydrogenase is the enzyme that converts DHEA to androstenedione, androstenediol to testosterone, and androstenedienol to androstenedienone, and then pregnenolone to progesterone. So this enzyme is extremely important for the conversion of upstream hormones into testosterone and other hormones as well. And then if we come down here, 17-beta hydroxysteroid dehydrogenase is important for a similar reason. So conversion of androstenedione to testosterone, dihydrotestosterone to 5-alpha androstenedione and 3-alpha androstenediol, and then 20-alpha hydroxyprogesterone to progesterone, and then estrone to estradiol. So this enzyme here is also extremely important for hormone conversion. So we're going to look at the function in the different diets here. Something I want to point out here is that with the effects of the different types of fats on the testicles here may actually have relevance on the effects in the pituitary, or not the pituitary, in the ovaries as well, because these same enzymes are present inside the ovarian tissue. So something to keep in mind. Now, the 3-beta hydroxysteroid dehydrogenase, so this enzyme here, it had a much higher function in the olive oil and the coconut oil groups, almost 3 times as much function in the olive oil and coconut oil groups compared to the grapeseed oil group, and about almost twice to 1 times as much function in the olive oil and coconut oil group respectively compared to the soybean oil group. So even the steroidogenic enzyme function is better inside the olive oil and coconut oil fed rats' testicles compared to the soybean oil and grapeseed oil fed rats. And then the same deal for the 17-beta hydroxysteroid dehydrogenase. With the olive oil fed rats and the coconut oil fed rats, we're looking at, let's see here, almost 4 times as much 17-beta HSD function in the coconut oil compared to the grapeseed oil, about 5 times as much function of 17-beta hydroxysteroid dehydrogenase in the olive oil group compared to the grapeseed oil group. We're looking about twice as much function in the coconut oil group compared to the soybean oil group, and then we're looking about maybe a little more than 2 times as much function in the olive oil group compared to the soybean oil group. So essentially, to wrap this all up, what we're seeing is decreased oxidative stress in the olive oil and coconut oil fed rats' testicles. We're seeing increased amount of antioxidant compounds inside the olive oil and coconut oil fed rats' testicles. We're seeing increased testosterone in the serum and in the testicles with decreased hypothalamic pituitary axis hormones like LH and FSH signaling on the testicles. And then we're also seeing improved steroidogenic enzyme function inside the olive oil and coconut oil fed rats' testicles compared to the soybean oil and the grapeseed oil fed rats. So overall, I know this is a rat study, but if you want to look at testicular function overall, it seems that olive oil and coconut oil are a much better way to go than soybean oil and grapeseed oil in terms of testicular function on numerous levels. So I guess that would be the biggest takeaway for this study. If you want your boys to work effectively, or ladies, if you want your man's boys to work effectively, don't cook with soybean oil and grapeseed oil. Use olive oil and coconut oil. Last thing here is I have the reference for anybody who's interested in checking out this study. Very interesting study. Kind of a simple one, an easier one to go through, not like the obesity one or whatnot, which has a lot more concepts. And again, keep me posted on what you guys think of this new format. I'm still trying to figure out which is the best way to go. Do I want to do the longer format? Do I want to break them down into these types of formats? Do I want to do a mix? Do I want to do both? And depending on what the input is, I guess I'll adjust from there and I'll keep playing with it and we'll see how we go. Hope you guys enjoyed this week's study. Stay tuned for the next one.